Going live. Great. Well, right. So Rachael Sanderson is going to talk about experimenting with social media data using open source software.
Yeah, brilliant. So I'm Rachael. I'm yet another person from the Geospatial Systems CDT in Newcastle, so we're a bit of a team. And to be honest, so this presentation is mainly looking at how I have approached using social media data, specifically data from Twitter, using different open source tools. And to be honest, it's mainly a thank you because I would not have been able to do the kind of different things I'm looking at if it wasn't for the open source tools I've been using. So just as an outline of the project, I'll be focusing more on kind of the methods and what I did than the actual theoretical background. But the project I'm looking at, I'm currently in the third year of my PhD, and I'm looking at how you might use different quantitative geospatial data sets to classify what's been termed as left behind places. So it's looking at regional inequalities, places that have experienced stagnation or decline. And this section in particular is looking at Twitter data, and the focus is how Twitter data has been argued to not be a completely representative data set. We're aware of biases by gender, race, age, income level, educational level, and this is looking specifically at geography. So if you're looking at the geospatial data that you can gain from Twitter, how might those geographies be varied? So we've got kind of key research questions of where are the places that are the most visible in the Twitter network, and how does that vary? And do the literatures overlap? It's an exploration. What are we going to find out? So the data was initially downloaded in our studio using the R-Suite package. So just set it up as a desktop in the office, start collecting the data with the live stream. So kind of setting the code up, you can do things like setting up a bounding box. So I did it for kind of covering England and Wales for how it overlapped with different administrative data. And whilst I didn't do that, you can filter in terms of different keywords. You can filter looking at specific times and over a long period of time and choose how you're going to do that. Store the data in the JSON, and then I'd convert it into a CSV file because that's my preferred file format.
Rachel, I'm really sorry to interrupt. We think the screen's going to turn off again. We're not sure why.
Oh,
just
okay.
When it does, we'll turn it back on again.
Okay.
Sorry to interrupt your flow.
That's fine. So as you can see, you get quite a hefty download, but I did actually filter out quite a bit and only actually used about 4 to 5% of data. And that's because the coordinate information you get comes in two forms. It can be precise locational coordinates generated by your mobile phone. You can also get some that are generated by Twitter, that I think are done kind of by nearby maps. And the issue with those generated coordinates is that they're done at a range of scales. So you can have points of interest. That's almost precise. I can talk about this bit without screen. That's almost precise. Or it can go as large as you can go to city level, administrative level, but you can also end up at national level, which is all well and good, but you end up with a massive spot in the West Midlands that's a really big hotspot. If that's still not going to come on. Oh.
Needs to be under HTML first.
Oh, come on.
There we go.
Right. Sorry, have to set up your. Sorry. Great.
Does that work? Yay! Okay, brilliant. So yes, it can scale from. I also now don't have my timer, so I now have no idea how long I've been talking for because it's gone.
6 minutes left.
Okay. Yes, it can scale from kind of points of interest to national level, but if you're using the national level coordinates that it's generated, they're done off the center point of a bounding box. So if you've got a national bounding box, you suddenly, for example, have a massive hotspot of points right in the center of, I think it was in the West Midlands, where there's pretty much no population. So you do need a careful filtering of the coordinates. You also need to filter the box. So for example, I removed accounts that accounted for about 1% of all tweets and accounts that seem to be overly active in tweeting from the same location. And I did this using PostGIS and SQL. And again, thank you open source community, GitHub. There was a paper that had deliberately got open source code and kind of shared their work. And that saved so much time, and especially as someone who had pretty much no experience with SQL, the ability to use, and obviously full credit to people who are able to who share their code. So then going on from that, filtered down to just looking at England and Wales, obviously tweets are collected for a bounding box, and then group this by MSOA. So just as a brief introduction to some results, surprise, surprise, areas with higher population density are the more yellow, areas with higher tweet density in the more yellow. Guess what? More people tweet, more tweets come from where there's more people. Unsurprising. So we then looked at matching, kind of looking at tweets per 1,000 residents, which creates a bit more of a scattered pattern. And we could kind of see some areas of higher or lower activity, but I found this quite hard to interpret because partly because of how MSOAs are as a border. So again, looking at open data, House of Commons Library has a really nice cartogram that supported the visualization of MSOAs. So if I compare the two maps where you've got, say, really small MSOAs in London, because they're built on population, not all the same area, in my opinion, I found the cartogram quite good because it means you get the rural areas that look bigger, kind of a bit more shrunk down, and so that helps visualization. So again, in terms of looking at the results, still a bit foggy, but I found the visualization worked well. And again, thank you for open source for kind of the different things that you can do. My next stage was to look at a multiple linear regression. So the idea is I'm almost deliberately trying to produce a model that will fail, i.e., I take variables to describe the population. These variables are all things that are known to be linked to people who are more likely to be posting in Twitter. So areas that have higher income, areas that have more population, looking at the age of population. Put these variables into a linear regression model. Where are my residuals? Where are the areas that have more Twitter activity than expected? Where are the areas that have less? A bit I don't go into this presentation is that there are some variables to do with left behind places that I leave out of the initial model. They get then added in to see what the impact is. I don't discuss it in this, but that is kind of the next stage of the analysis. So again, thank you open source in terms of looking at how we can produce visuals within our studio to understand the linear regression. Produce two models, one looking purely at MSOA characteristics, one with all the characteristics. I can happily talk about the results until the end of time, but I think the things that I really want to highlight, again, thinking of how we use open source, is producing different visualizations. I recently went to a conference that is very much death by regression table, and it's quite dull. Researching different ways to present the results, I found was really, really helpful. And you can see how the coefficients change when you're using different models and things like that. So, for example, it's now much more clear to see that the highest contributing variable was the amount of working population in an MSOA, and one that kind of reduced actually was about the net income. So, again, it's things that you're able to do with open source. Again, I'm appreciative for the kind of community that there is. And also then for using R as a GIS. So all my maps were produced using TMAP, and you can even then, so using kind of spatial dependency packages, looking at, so that's the map of the residuals, but we can see areas that have got, so red indicates areas that are hotspots, that are areas that have got more Twitter activity than was expected, and the blue are areas with less clusters of less Twitter activity than was expected. So that's using the Jessisor GI significance. And I think the thing that was found interesting, and I'm still diving into the results are, so this is a map showing left behind areas that have been calculated within just one example study. You've got an area with more left behind places over here that links to a cold spot, but you've got an area left behind here that links more to a hot spot. So not quite sure what's going on. London is very often an anomaly, and that's something kind of to be accounting for in the data. But again, it's seeing the fact that through our studio I've been able to do all of this, and that's been really invaluable for looking at the work and for how I'm going forward. So overall, as kind of a summary of the different things, is that through our studio I've been able to access Twitter data, and I've been able to form analysis and look into it a bit further. And so that's right from the stages of downloading and filtering right to producing the visualizations. And there's still so much more that I can look at out there, which is what's fantastic. And then in terms of the actual results, I've not really gone into it because that's not the point of this presentation, but there is scope for further investigation, and I know that there's going to be even more open source stuff for me to look at. So in terms of future work, I'd say some things to look at. I want to look more at Twitter content, so look at what people are talking about. You can look at sentiment analysis, looking at kind of positive and negative tweets, and I've seen a lot of that I've experimented with in terms of using things like tidy text. I want to look into more at the geographies of it, so for example, using kind of overlapping to looking at the Twitter data of where are the areas of high concentration, linking to the base maps, for example, that you can get through OpenStreetMap. And trying different boundaries. So, for example, there's the hexagonal package that the name has slipped my mind, and looking at how different. I've looked at how MSOA characteristics seem to influence the results. So, how might different boundaries change that? So that was very much kind of a run through of that. So yeah, thank you to the CDT for funding me. I generally do store my code on GitHub, but none of this is on yet because I have a habit of waiting and trying to tidy it up first before I put it on GitHub. But yeah, I definitely welcome thoughts on different things that might be out there for me to maybe try. So thank you very much.